Good morning, students. Today we will discuss class 10 science chapter 1 chemical reaction and equation. In this chapter we will discuss about chemical reaction, chemical equation, characteristics of chemical reaction and type of chemical equations. First, let's understand what is chemical reaction. A type of process in which two or more substances combines to form new substance is called a chemical reaction. Example, burning of charcoal in air to form carbon dioxide. Students, number of a process takes place around us. That process may be physical or that process may be chemical. How to identify a given process as chemical or physical? If two or more substance in any process combines to give us a new product with entirely different properties, we say that process as a chemical reaction. Let's understand. Giving example, burning of charcoal in air forms a carbon dioxide. So charcoal burning, we all are very much familiar with the burning of a charcoal. It's a chemical process because while burning of a charcoal, charcoal combines with air to form carbon dioxide. We started with the charcoal, we end up getting carbon dioxide. So here the new substance is formed, carbon dioxide. We didn't start with the carbon dioxide, we started with the carbon and we got the carbon dioxide. That's what we mean by new substance. And the properties of the charcoal has changed. Charcoal was a solid black porous substance. Now we have carbon dioxide, which is gas. Carbon dioxide. Let's talk about chemical equation. A shorthand representation of a chemical reactions using the symbols and formulas of the substances taking part in a reaction and the new substance formed during the reaction is called a chemical equation. Burning of charcoal is a chemical reaction. If I want to translate this chemical equation, if I want to make this chemical equation short and simple, how to do this? Now, to make this chemical reactions simple, we have a way out, that is to express this chemical reactions in the form of a chemical equation. Let's take the example, burning of charcoal. Burning of charcoal in air to form carbon dioxide. If I want to express this reaction simple and concise way, I can use mathematical equation to do that. Charcoal. Now this charcoal is represented by the symbol carbon and air. From the air we get oxygen, so this air is represented by oxygen, and when these two combines we get carbon dioxide, so this carbon dioxide is represented as CO2. So now if you compare this chemical reaction and this chemical reactions, both of these reactions represent the same reaction, but there is a difference. The difference is this reaction is written in a sentence form and this is written in a chemical equation form. If you compare the importance, this reaction is concise and giving us the same information that is given by this chemical reaction. So if any chemical reaction is given to us and if we are asked to express this chemical reactions in a shortest possible way, the best way to represent that chemical reaction in the shortest possible way is to express that chemical reaction in the form of a chemical equation. And this is what chemical equation is. So we studied about the equations in maths. You know, equations have two parts, left hand side and right hand side. So in this chemical equations also we have a left hand side and right hand side. So This is the left hand side of the equation where we have carbon and oxygen taking part in a reaction. So this part of the reaction where we are representing the substance taking part in a reaction is called a reactant. And the right hand side of this equation where the product is formed, this part of the reaction is called a product. So left hand side of a chemical equation is called a reactant, and the right hand side of the chemical equation is called a product. So this is how we can represent a given chemical reaction in a simplest way, that is expressing the chemical reactions in the form of a chemical equation. What is the need of a chemical equation? Let's understand. Expressing chemical equation, it's quite handy, it's time saving, and it's universal. Now you can compare this reaction and this reaction. This is written in a sentence form. It's very long, time consuming, space consuming, and not universal. Now when I say universal, what does it mean? When I say universal, it means given a reaction, if you are asked to write the students, this number of students, they may write that reactions in a different way. Say suppose this reaction, charcoal burns in air to form a carbon dioxide. One of the students may write this reaction as charcoal burns in air, forms carbon dioxide. Another student may write the same reactions in a different form, like carbon dioxide is formed when charcoal burns in air. So different students they may have a different way of expressing the chemical reaction. But if we write these chemical reactions in equation form, all the students will be writing these chemical reactions this way: C plus O2 CO2. This is what I mean by being universal. So expressing chemical reactions in the form of chemical equation is quite handy. It's time saving, space saving, it's less laborious, and it's universal. So that's the importance of chemical equation. That's the need of chemical equation. Okay, students, let's move on to another topic. That's the characteristics of a chemical reactions. Now, a number of a process which is going on around us, that may be physical process, that may be chemical process. How to identify a given process as a chemical reaction? So there are certain observable features, characteristics. If we can spot that characteristics in a chemical reaction, a chemical process or a process in general, at once we can understand the given process is a chemical reaction. If you can see any of these observable characteristics, formation of a gas, during a process, if a gas is formed, that's the nature, that's the indication that the chemical reaction is going on. If there is a formation of a PPT, now PPT stands for precipitate. Precipitate. What is the meaning of a precipitate? Precipitate is insoluble substance formed during the reaction. That is called precipitate. So if there is a formation of a precipitate during the reactions, we can understand the given process is a chemical reaction. If there is change in temperature during the reactions, the energy may be released or energy may be absorbed. That means the temperature of the system where we are carrying out the reaction may increase, may decrease. If there is a change in temperature, the temperature is increasing or decreasing, we say the given process is chemical reaction. We may find change in color. During a process, if there is a change in color, we can conclude the given process is a chemical reaction. So if we find any one of these four characteristics taking place in a process, we can understand at once the given process is a chemical reaction. So what are those characteristics? It's the formation of a gas, formation of a precipitate, change in temperature, change in color. If we can see any one of these four characteristics in any process, we can say the given process is a chemical reaction. That's how we can identify the chemical reactions. So that's all about this topic. Now let's move on to another one. Types of chemical equations. How many types of chemical equations are there? Just a while ago, we discussed about the chemical equations. Now you know what is the importance of the chemical equations. Two different types of chemical equations are there. It's a balanced chemical equations and unbalanced chemical equations. Here is an example. Balanced chemical equation C plus O2 CO2. An unbalanced chemical equation H2 plus O2 H2O. Let's understand what is balance and unbalance. As the name itself says, balance. That means the left hand side and right hand side of the equation is balanced. So in an equation, if you have the same number of elements, both sides of the equation, same number of atoms of each of the elements, both sides of the equations, we say the chemical equation is balanced. In this reaction, you can see the type of elements. Left hand side, we have the same type of elements, that's a carbon and oxygen. Right hand side also, we have the same type of elements, that's carbon and oxygen. If you count the number of atoms, left hand side and right hand side, you'll see the same number of a carbon atom. Carbon 1, right hand side. Oxygen 2, right hand side. So this equation, you have the same number of elements, left side, right side, and same number of atoms, the right side and left side. So the equation is balanced. But if you compare this reaction, you have left hand side hydrogen 2 atom of hydrogen. Right hand side also you have 2 atoms of hydrogen. Left hand side you have 2 atom of oxygen. Right hand side you have only 1 atom of oxygen. So oxygen atom is not same, not equal both sides. So this equation is not balanced. Okay students, let's understand the need of balancing. Now you know what is balanced and unbalanced chemical equation. So let's understand what's the need of balancing a chemical equation. Student, we understand during the chemical reaction, the mass is always conserved. When I say mass is always conserved, what does it mean? We know from our previous classes, during the chemical reaction, the mass remains conserved. During the chemical reaction, before the reaction, what was the total mass? After the reaction, total mass remains the same. That is, mass is never destroyed. Mass is neither created nor destroyed. That's what the law of conservation of a mass. So during a chemical reaction, mass should always be same before the reactions and after the reaction. So if a chemical equation is balanced, it means the mass before the reaction and mass after the reaction remains same. So law of conservation of mass is followed. But unbalanced chemical equation, in unbalanced chemical equation, mass before the reactions, mass after the reactions never equal. That means in unbalanced chemical equations, the law of conservation of mass is violated. Law of conservation of mass is violated. So that's why we have to balance the chemical equation so that the law of conservation of mass is never violated. So I hope you understood why the balanced chemical, what's the need of a balancing chemical equations. Let's move on and see the next topic, how to balance chemical equation. Given a chemical equations, you have to check the given equation is balanced or not. If it is balanced, it's good. If it is not balanced, we have to balance it. So let's see. We have first equation H2 plus O2 H2O. You have same number of elements left hand side, same number of elements right hand side. 2 atom of hydrogen left hand side, 2 atom of hydrogen right hand side. 2 atoms on the left hand side of the oxygen, left hand side. 1 atom on the right hand side. So this equation is not balanced. So we have to balance it. Now students, before we balance this chemical equation, we must keep some of the points in our mind. You can see here, when you're balancing atoms, you must see all the metal atoms are monoatomic. Remember this point, all the atoms are always monoatomic. And there are some elements which are always expressed in their molecular form during the reactions. So what are those elements? Hydrogen is expressed as H2, nitrogen is a N2, oxygen is a O2, fluorine is a F2, chlorine is a Cl2, and iodine as a I2. So if you remember these points will help you balance the chemical equations, balancing chemical equations. Let's understand. Come back to this point. Hydrogen plus oxygen, H2O. So we have 2 hydrogen here, 2 hydrogen here, 2 oxygen here, 1 oxygen here. So oxygen is not balanced. And one more thing, student, while balancing this chemical equation, we are not allowed to change this indexes. We are not allowed to introduce any new indexes, and we are not allowed to delete or remove any indexes. What we are allowed to do is we have to just introduce the appropriate coefficients here, here, or here. Wherever needed, you introduce the coefficients and make the equation balanced. Let's have a look at this. Hydrogen 2, it's balanced. Oxygen 2, oxygen 1. Oxygen is not balanced here. That means we have to balance this oxygen. So what I can do is introduce appropriate coefficients. Let me write this 2 here. If I write this 2 as a coefficient, this 2 counts for both this hydrogen and oxygen. Now we have 2 oxygen. This 2 also counts for this. How many hydrogen are there now? We have 2 2s are 4 hydrogen. So we have balanced this oxygen. We have 2 oxygen left hand side, 2 oxygen right hand side. But while introducing this 2, we disturb the balance of hydrogen left hand side and right hand side. We have 4 hydrogen on the right hand side now. We have only 2 hydrogen on the left hand side. So we have to make this hydrogen also 4. Now to do that, we'll introduce the coefficients here, 2. So 2 to the 4 hydrogen, 2 to the 4 hydrogen. Hydrogen is balanced. 2 oxygen, and now we have 2 oxygen. This 2 counts for this, remember this. So this 2 is also for oxygen. So we have 2 oxygen. So this equation is balanced. Let's move on to another one. We have aluminium plus oxygen, Al2O3. We have 1 aluminium, we have 2 aluminium, right hand side. So we should have a 2 aluminium on the left hand side also. So we have to introduce the coefficient here, 2. So 2 aluminium, it's balanced. We have 3 oxygen, we have 2 oxygen here. Now, how can I make this oxygen 2 as a 3? We cannot do that. Can I make this oxygen 3 as a 2? Not possible. So what we can do is introduce the coefficient here, 2. If I do this, I'll make this oxygen 6. 2, 3 is a 6 oxygen. Now we have to make this oxygen also 6. Now to do that, we'll introduce 3 here. 3, 2 is a 6 oxygen. So we have balanced oxygen. But while introducing this 2, we disturb the balance of aluminium atoms. We have made aluminium atoms 4 on the right hand side. So we should have 4 aluminium atoms on the left hand side also. So we have to make this 2 as a 4. So this is 4 aluminium, 3 to the 6 oxygen, 2 3 to the 6 oxygen. That's how this equation is also balanced. Now let's move on to third equation. We have calcium oxide plus water and calcium hydroxide. Now check the number of atoms of each of the elements, both sides of the equation. So you have calcium 1, calcium atom is balanced. Hydrogen 2, you can see this 2 is outside this bracket. It means this 2 counts for both oxygen and hydrogen. So we have 2 hydrogen. So 2 hydrogen. We have 1 oxygen. Be careful. We have not only 1 oxygen plus 1 oxygen here. So 1 oxygen here, 1 oxygen here. Total of a 2 oxygen on the left hand side. So we have a 2 oxygen on the right hand side as well. So that means this equation is already balanced. So we don't need to balance this equation. It's already balanced. Now move on to another one. Magnesium plus HCl gives magnesium chloride plus hydrogen. We have 1 magnesium, 1 magnesium. Magnesium atom is balanced. Hydrogen 1, hydrogen 2. So we don't hydrogen 2 right hand side. So we should make hydrogen 2 on the left hand side as well. So make this 2. So now magnesium 1, 2 hydrogen, 2 hydrogen. We have 2 chlorine. Remember this 2 counts also for this chlorine. So 2 chlorine, and here also we have 2 chlorine. So this way our equation is balanced. So I hope you understood how to balance the chemical equations. So while balancing chemical equation, you must remember all these points that will help you balance chemical equations. Okay, that's all about the chemical equation balancing. Now let's move on to another topic. How to make chemical equations more and more informative. See students, we understood the importance of chemical equations. Well, expressing the chemical reactions in the form of a chemical equation, that saved our time, that saved our space, that made the expressing chemical equation universal. Now, I want to extract more information out of this chemical equation. How can I do this? So, to make the chemical equation more informative, here are 3 ways to do the same. Mention the states of the reactant and product. See, here is the example. We have carbon plus oxygen, CO2. If I write C plus O2 as a CO2, this reaction and this reaction, if you compare both these reactions, you will see this reaction, this equation is giving more information as compared to this. From this equation, you can understand this carbon is a solid, this oxygen is a gas, carbon dioxide is a gas. No such information is available from this equation. So that's how. Mention the state of the reactant product. We can make the equation more informative by mentioning the state of the reactant and the product. Now, one more example, see hydrogen gas, oxygen gas, when they combine to give us water, it's a liquid. So now we know water exists in all the 3 states, solid, liquid and gases. So now if I simply write H2 plus O2 as a H2O, just by looking at this formula H2O, we don't have any idea whether this water exists in the form of a liquid or solid or gaseous. But from this equation, it's very, very clear that water is in the form of a liquid. Water exists in the form of a liquid. So that's the information we can extract from the chemical equation. We have third reaction. Calcium oxide solid, water liquid, and calcium hydroxide AQ. Now this AQ stands for aqueous. So that's how we can make the chemical equation more informative by mentioning the state of the reactant and the product. S for solid, L for liquid, G for gas, and AQ for aqueous. So now see second way, how can we make the equations more informative? more and more informative. Mention the reaction conditions. When I say mentioning the reaction conditions, for the reactions to occur, they need certain conditions. Under certain conditions, some of the reactions may initiate or may occur. So how can we do that? Take this example. Carbon monoxide plus water combines to give us methanol. But for this reactions to occur, we need a pressure of 340 atmospheric pressure, 340 atm. So this is how we can express the reaction condition. That means for this reactions to occur, we need a pressure of 340 atmosphere. So this is the reaction condition. This is how we can express the reaction condition. We have one more condition. Carbon dioxide plus water gives us glucose plus oxygen plus water. That's a very famous reaction. We all know this. This is a photosynthesis reaction. Now for this photosynthesis reaction to occur, we need sunlight and chlorophyll. So this is the reaction conditions. So this is how we make the chemical equation more and more informative by expressing the reaction conditions. We have one more way to make the chemical equation more informative. Mention the energy released or absorbed. Some of the reactions, energy may be released. Some of the reaction, energy may be absorbed. So whether the reaction is energy is released or absorbed, we can express this way. Take the example of this reaction. C plus O2 is a CO2. So this is a burning of a charcoal. So during the charcoal burning, what happens? Energy is released in the form of heat. So if energy is released, we write that energy on the right hand side of the equation as a plus energy. Now some of the reactions, for the reaction to proceed, they may need the energy. So if energy is needed, if they absorb the energy, that absorbed energy is expressed here above the arrow. So in this reaction, you can see calcium carbonate absorbs, or they need energy in the form of heat, and it undergoes decomposition to give us calcium oxide and carbon dioxide. So this is the reaction where energy is released. So if energy is released, we express the energy on the right hand side of the equation as a plus energy. And if energy is absorbed, we express that energy as heat or energy above this reaction arrow. So this is how we can make our chemical equation more and more informative.